How can I use the distributive property to simplify expressions? So in this video, I'm not going to necessarily have a lot of problems typed out for you. I'm going to read them to you straight from some of the stuff we've been working on in class that people have been struggling with, and just kind of go over how to solve some examples. I'm going to do 4, and I'm going to really just focus on also setting it up in like a 3-column note taker. So in the first problem, I'm going to look at it. It's Tanya plans to make a photo frame with an area of 32 plus 12 square inches. The length of the frame is 4 inches. What is the width of the frame? So we're looking for a width of a frame. Now, in order to figure this out, we need to know the area equals length times width. And when we do length times width, we can also use the fact family to say I'm trying to figure out width. So that would mean width equals area divided by length, which equals A over L. Now, in this problem, we've been given the area is 32 plus 12R, and we've been given the length of 4. Now we can use the distributive property to distribute a division over addition. And we do that by dividing 4 into 32 and 4 into 12. So we do 32 divided by 4 plus 12 divided by 4R. We solve this and say 32 divided by 4 is 8, plus 12 divided by 4 is 3R. So that becomes our solution. 8 plus 3R is the simplified expression that would equal the width. In our next example, we're going to again deal with an area problem. So again, we'll need to know the area equals length times width. Here's the problem. You have builders. They plan to build a room with a length of 15 feet and a width of 10 feet. So initially, you can have your length of 15 and your width of 10. And so here's the diagram that would represent that. They decide the width has to be reduced by y feet. So again, we look back at the problem, and the width was labeled as 10. So we're going to be taking 5 feet off of this. So this whole side here is going to still be 10. Now this part is going to be y. This part would still be 15, and this part would be 10 minus y. So we need to kind of understand how this new area works. So then it wants us to pick an expression that correctly shows the new area that the room will be. So in this case, we're looking at the room, so we're ignoring this part. I'm looking at the room, which would be 15 times this side, which is 10 minus y. Now, this could be the expression, 15 times 10 minus y. There's another way that you could choose to write it as well, and that would be distributing the 15 over the 10 and the y. Sometimes referred to as expanded. I would almost refer to it as like simpler. It's not. It's going to be an equivalent expression. 15 times 10 is 150, minus 15 times y is 15y. So you have two choices for an answer here. We're looking for expression for area, and the expression for the area would be 15 times 10 minus y, or 150 minus 15y. It's a 1 there, 150 minus 15y. Both of those would be potentially correct expressions. I would say that this might be the preferred one. And we'll go on to another example. All right, in this example, we're going to be looking to find the area, an expression to represent the area of a rectangle. So we have the person's name is Mia. They plan to make a tabletop with a length of 4 feet and a width of 2 feet. This is the diagram that shows that. But then she goes and decides that she's going to increase the width, which was 2, by x feet. So you add on to the table an x. What expression correctly shows the new area? So again, area equals length times width. So it would be 4 times 2 plus x, and that would be a potential expression. The other potential expression would be 4 times 2 would be 8, plus 4 times x would be 4x. And I'm going to go ahead and say 8 plus 4x is my answer, 8 plus 4x. Okay, in this last example, you want to find an equivalent expression to 2/3 times 3/2 c plus 27. So to find the equivalent expression here, you just need to distribute the 2/3 over the expression. So you do 2/3 times 3/2 c plus 27 over 1, and I'm going to have to expand this out, times 2/3. And then we're just going to multiply these fractions and these fractions. In this case, I can actually, when I'm multiplying these fractions, I can do 2 times 3 is 6, and 3 times 2 is 6, but that equals 1. You could also have cross-canceled. 3 goes into 3 once and once, 2 goes into once and once, and you see that it would still be 1c. So 6c is going to equal just c. And then over here, 27 over 1 times 2/3, you can cross-cancel this. 3 goes into 27 9 times. 3 goes into 3 once. 9 times 2 is 18. 1 times 1 is 1, so it ends up being 18 over 1. And then it ends up being c plus 18. So coming back up to your equivalent expression would be c plus 18 would be the equivalent expression, which actually is a lot cleaner. So sometimes the distributive property, if you start with something with a bunch of fractions in it like here, if you distribute that out coincidentally in this problem, it worked out to be something that just seems like taking a number and adding 18 to it's a pretty simple step to do. So again, these are 4 examples of some problems taken straight from 10 marks that are going to help us use the distributive property to simplify expressions.